Real chicken, authentic spices, fresh vegetables, all in one cube. Maggie chicken stock, packed with flavor, created from nature.
We all know this humble chicken cube. It is a staple in our kitchen, packed with intense, savory flavor. But from a chemist's perspective, this cube is a couple matrix of proteins, fat, and a very specific target analyte, which is sodium chloride and common salt. How much salt is actually hidden in this concentrated cube? And how can we measure it precisely down the milligram without relying on the labels? And in this presentation, we will explore how we take this everyday food item, dissolve it, and use precipitation gravimetry to physically separate, isolate, and weigh the exact amount of salt it contains.
Assalamualaikum warahmatullahi wabarakatuh. Today our group are going to present about determination of salt NSL in a chicken stock gravimetric analysis. For theory, the foundation of our experiment is precipitation gravimetry. This involves separating an analyte from a liquid sample by converting it into an insoluble solid, which is then weighed to calculate its original concentration. For the chemical reaction, when silver nitrate AgNO3 is added to the chicken stock, it reacts with the dissolved sodium chloride NaCl in a double displacement reaction. The silver ions Ag plus bond with the chloride ion Cl minus to form a white insoluble precipitate of silver chloride AgCl. Let's take a look at the diagram. So inside the chicken stock, the salt and NaCl is completely dissolved into a free-moving ion, which is Na plus and chloride ion Cl minus. When we add the silver nitrate, it releases silver ions Ag plus into the storage region. Because silver has an extremely high affinity for chloride, they instantly bind together upon collision. This forms a solid network called an AgCl lattice, which appears as a dense, white precipitate. Since it's completely insoluble, we can easily filter, dry, and weigh the solid to calculate the exact salt content. Next, we'll talk about the chemical equation. AgNO3 plus NaCl becomes AgCl plus NaNO3. For the key precipitation, which is the Greek principles, first one we have the stoichiometry. Because the reaction occurs in 1/1 molar ratio, the number of moles of AgCl recovered is equal to the moles of Cl minus originally in the chicken stock. Digestion and purification. Heating the solution allows the colloidal AgCl particles to coagulate into filterable aggregates, which are then washed with dilute nitric acid, HNO3, to prevent peptidization and remove matrix interference like fats and proteins. Third, quantification. By measuring the final constant mass of the dried precipitate, we use the gravimetric factor, the ratio of the molar mass of NaCl to AgCl, which is 0.4078, to mathematically determine the precise amount of salt in the sample.
Now, let's walk through the experimental procedure, which begins with sample preparation and precipitation. First, for sample preparation, we accurately weighed out 10 grams of our chicken stock sample using the analytical balance. We then completely dissolved the sample in approximately 100 ml of distilled water within a beaker to free the chloride ion into the solution. Second, we move the precipitation of chloride. Before adding our main reagent, we add few drops of dilute nitric acid. These create an acidic environment that prevent interference from other potential ions, such as carbonate or phosphate. Once acidified, we slowly add our silver nitrate solution while stirring. We keep adding it until we observe that no more white precipitate is forming, ensuring all chloride ions have successfully reacted. Once the reaction is complete, we move on to digestion and filtration to isolate our analyte. In step 3, digestion, we gently warm the mixture around 60 degrees and let it sit for about 30 minutes. This thermal process allows the tiny colloidal silver chloride particle to coagulate and clump together into larger, heavier aggregates that easily settle at the bottom. Next is step 4, filtration. We pass the mixture through a pre-weighed filter paper to capture our solid precipitate. To ensure it is completely pure, we wash the trapped precipitate with a small portion of cold distilled water. We continue this washing process until the filtrate test completely free of excess nitric ion, which we verify using diphenylamine or litmus test. The final phase of our procedure involves drying, weighing, and quantitative analysis. In step 5, drying, the wet AgCl precipitate is placed inside a drying oven set to approximately 120 degrees or left inside a desiccator. We keep it there until a constant mass is achieved, ensuring all residual water is completely driven off. For step 6, weighing, we allow the crucible and the dry AgCl to cool down completely inside a desiccator so it doesn't reabsorb ambient moisture. Then, we take its mass on the balance and subtract the initial tare weight of the empty filter or crucible. This gives us the exact precise net mass of our solid AgCl precipitate. Finally, in step 7, the calculation phase, we apply our gravimetric factor of 0.4078 to mathematically convert the mass of the recovered silver chloride back into the mass of pure sodium chloride. From there, we determine the final percentage of salt present in our original chicken stock. Let's take a look at the actual calculation and data.
The calculation of steps to achieve the percentage of NaCl in the chicken stock sample. First, we must calculate the gravimetrical factor, which we are going to use the formula of molecular weight of Cl over molecular weight of AgCl times mole of Cl over mole of AgCl. As a result, we have got 0.2.5. And then next, we must calculate the mass of Cl, which we must use the formula of gravimetrical factor times mass of AgCl, which is the precipitate, 6.17. As a result, we got 1.5117 gram. Next, we must calculate the mole of Cl, which we will use the formula of mass of Cl over relative molar mass of Cl. Once you calculate, we will receive 0.0426 mole as the answer. Next, we must use the equation. Through the equation, you will see that mole of NaCl and mole of Cl is the same. So 0.0426 mole is a mole of NaCl. Once we obtain the mole of NaCl, we must calculate the mass of it. So now we will use the formula of mole of NaCl times molecular weight of NaCl. As a result, we got 2.5921 grams. Lastly, we need to calculate the percentage of NaCl in chicken stock sample. We need to use the formula of mass of NaCl over mass of chicken stock sample times 100. 2.4921 over 10 times 100, we got 24.9% of NaCl in the chicken stock sample.
I'm going to presenting the result and discussion of our gravimetric analysis experiment, where we determine the percentage of sodium chloride or common salt in commercial chicken stock sample. The primary objective of this experiment was to isolate and quantify the salt content using precipitation gravimetry from a 10-gram sample of chicken stock. We successfully precipitated 6.17 grams of silver chloride by applying a gravimetric factor of 0.245. We determined that our sample contained 1.5117 grams of chloride ions, which is translates to 2.4921 grams of pure sodium chloride. Ultimately, this gives us experimental salt positive of 24.9%. For comparison with commercial standard, to understand the accuracy of our result, we compare it to a standard commercial benchmark, a Maggi chicken stock cube. Based on literature data, a typical 10-gram Maggi cube contains about 1.6 grams of sodium. Through stoichiometric conversion, this equates to critical salt content of 26.25%. As you can see, our experimental value of 24.9% is noticeably lower This discrepancy suggests that the sample we analyze might have a low sodium variant, a different commercial brand altogether, or perhaps a homemade formulation which is naturally contain less concentrated salt than commercial cube.